Dear student and viewers, Assalamu alaikum. It is our fourth lecture of class 10. Our topic is today simple pendulum or show that the motion of simple pendulum is simple harmonic motion. इससे पहले हमने ये प्रूव किया था कि स्प्रिंग मास सिस्टम जो है यानी स्प्रिंग के साथ जब मास अटैच करे तो इसका मोशन जो है सिंपल हार्मोनिक मोशन है. Today now we'll prove that the motion of simple pendulum is also simple harmonic motion. So for this purpose we can consider a pendulum which is attached to a length L to a support. When pendulum at a mean position point O, then there are two equal but opposite forces acting on it. One is called tension, which is upward, and the other is weight, which is moved downward. So both forces are equal, so they can cancel the effect of each other. But when the pendulum is displaced to one side, suppose that point A, here the force is resolved into two components. One component is mg cos theta, which is along y-axis, and the other is mg sin theta, which is along x-axis. Here along y-axis mg cos theta is equal to the tension, so tension is equal to mg cos theta, so they can cancel the effect of each other. But only one force, which is called a restoring force, and that restoring force is equal to mg sin theta, is responsible for the motion of simple pendulum. So this restoring force is equal to the applied force of the pendulum. So applied force is equal to the negative of the restoring force. Here negative show that the motion of pendulum is always directed toward the mean position. According to Newton's second law, F is equal to ma and restoring force is equal to mg cos theta. So putting this value, we will get ma is equal to mg sin theta. Here we cancel m both sides. A is equal to minus g sin theta. As sin theta is very small, therefore it is approximately equal to theta. So we will put theta instead of sin theta. So we will get this equation A is equal to minus g theta. अच्छा, हम अब फिगर की तरफ आते हैं. हमारे पास जो ऊपर वाला सिंपल पेंडुलम का फिगर है, इसका लेंथ L है, जिसको हम ओ बी से रिप्रेजेंट करते हैं, और ओ ए जो है इसका डिस्प्लेसमेंट x है. तो इससे हमारे पास एक ट्राइंगल बनता है, और ये ट्राइंगल कुछ इस तरह है, ए ओ बी. From this figure we know that tangent theta is equal to x over L, but we also know that tangent theta is equal to sin theta divided by cos theta. So we will get sin theta divided by cos theta is equal to x over L. जैसे कि हमने बयान किया था कि यहाँ पर थीटा जो है बहुत ज़्यादा स्मॉल है, सो cos theta is equal to 1. So we'll get sin theta divided 1 is equal to x over L, or sin theta is equal to x over L. Or we can also write that theta is equal to x over L, because sin theta is very small. So that is our equation 3. So now we will put equation 3 and equation 2. So we will get A is equal to minus g x over L, or A is equal to minus g over L into x. यहाँ पर g और L both are constant, because g is a gravitational constant and L is constant, because the length cannot be changed of the simple pendulum, because this pendulum time period is only depend upon the length of the pendulum. So both are constant. So now we will get this equation A is equal to minus g over L and x, or A is equal to minus constant x. So we will put constant instead of proportional sign, so we will get SHM. So this equation show that the motion of simple pendulum is simple harmonic motion. अच्छा, तो ये प्रूफ हो गया कि सिंपल पेंडुलम का मोशन सिंपल हार्मोनिक मोशन है. अब हम सिंपल पेंडुलम का जो टाइम पीरियड जो है, टाइम पीरियड इज इक्वल टू 2 ओवर जी अंडर द रूट. अब हम ये प्रूव करेंगे कि इसका टाइम पीरियड जो है इसके बराबर है. एज वी नो दैट A is equal to minus g over L into x, जैसे कि ऊपर इक्वेशन में हमारे पास आया, तो ये इक्वेशन और है सपोज. But we also know that angular acceleration which is equal to A is equal to minus omega square x, that is equation 5. So now we will compare equation 4 and 5. We get minus omega square x is equal to minus g over L into x. Minus minus cancel और x cancel करें both sides से. So omega square is equal to g over L और omega square under root is equal to g over L under root. Now we'll take under both side. ये cancel होगा इस square root के साथ. Omega is equal to g over L under root, that is equation 6. अच्छा, हम टाइम पीरियड की तरफ आते हैं. हमारे पास टाइम पीरियड जो है एंगुलर मोशन, जब कोई ऑब्जेक्ट सिंगुलर मोशन करता है तो इसका टाइम पीरियड जो है हमारे पास बराबर है. टाइम पीरियड इज इक्वल टू 2 डिवाइड बाय ओमेगा. So this is equation number 7. So now we will put 6 in equation 7. We get omega is equal to, sorry, time period is equal to 2 pi डिवाइड बाय ओमेगा. यहाँ ओमेगा वैल्यू जी ओवर एल अंडर रूट है और टाइम पीरियड इज इक्वल टू 2 पाई एल ओवर जी अंडर रूट. इसका हम रेसिप्रोकल लेंगे, ऊपर जाएगा. सो टाइम पीरियड इज इक्वल टू 2 पाई एल ओवर जी अंडर रूट. सो दैट इज आवर फाइनल इक्वेशन. So from this equation it is clear that the time period of the time pendulum is only depend upon the length. So time period is directly proportional to the length of the pendulum. It means that time period of a pendulum cannot depend upon its mass of the pendulum is independent. It is only depend upon its length. If we increase or decrease the length, then the time period of the pendulum will be changed. So that is our topic today. So from this equation, from this topic, we know that what is the motion of simple pendulum is motion is simple harmonic motion, and we also prove that the time period of a simple pendulum is only depend upon its length. Thank you.